Good afternoon, everyone. I am Astha Lutare from Amtech IT 4th SAM, and today we will discuss question number 1 of the internal one. So, our question is: write an algorithm to accomplish the task for polynomial px given in the following table. Here we have given a polynomial px is equals to an x to the power n plus an minus 1 x to the power n minus 1 up to a1x plus a0. We have to write an algorithm for brute force iterative method and recursive method. So first we will evaluate px by brute force iterative algorithm. Steps are: we will start with the result is equals to 0 for each quotient ai from I is equals to 0 to n. Compute x to the power I, multiply x to the power I by ai, and at last we will add the result to the total sum and at last return the final result. In simple words, we can say that start with the result is equals to 0. For each term, calculate x to the power I, multiply with ai and add to the result, and at last repeat all the terms. Next, we will evaluate px by recurrence relation, which is also known as recursive approach. Steps are: to start with the result is equals to an, which is the highest degree term. If I is equals to n minus 1 down to 0, we will multiply the result by x and add ai to the result, and at last return the final result. Steps are: initialize result is equals to an for I is equals to n minus 1 down to 0, result into x plus ai. It is more efficient than brute force algorithm. Next, we will divide px by x minus r by brute force iterative algorithm. So, our steps are: begin with the dividend polynomial px. Second, determine the highest degree term in the quotient by dividing the leading term of the dividend by x minus r. Third, multiply x minus r by the quotient term. Fourth, subtract this from the current dividend to get new dividend. Fifth, repeat the process until the degree of remainder is less than 1. And at last, sixth, return the quotient and remainder. This is polynomial long division. We will divide the highest term by x minus r, multiply and subtract from px and repeat until the remainder is less than 1. This gives quotient and remainder. Now we will divide px by x minus r by recurrence relation. Steps are: first, we will initialize the value of the quotient as leading coefficient an. Second, for each next coefficient, that is moving left, multiply the previous result by r and add the current coefficient. Third, continue until all coefficients are processed. Fourth, the last value is the remainder and the rest are quotient and coefficients. It is faster and simpler method using coefficients. We will start with the leading quotient, multiply by r and next coefficient. We will repeat it till the end. The last quotient is the remainder and rest is the quotient. Third, we will differentiate px with respect to x by brute force iterative algorithm. The steps are: first, for each term ai x to the power I, compute the derivative as I x to the power I minus 1. Second, we will ignore the quotient term a is equals to a0. Its derivative is 0. Collect all new coefficients for the resulting polynomial and at last return the divided polynomial. Here we have to find the derivative of each term. The rule is d by dx of ai x to the power I is equals to I into ai x to the power I minus 1. Steps, we can simply say, is to skip the constant term, multiply each ai by I and create new polynomial from the result. Now we will do it by recurrence relation. Steps: for I is equals to 1 to n, multiply ai by I to get the new coefficient. It stores all the result as the new coefficient of the derivative polynomial. Return the list of derivative quotient. Simpler to brute force but use recursion to apply the derivative rule to each term. more useful when done programmatically. Thank you for listening.